Hey everyone! In the last couple of videos we mainly looked at how to break things up, but in this video we want to talk about how the pieces that we create actually look like, or how we add detail to them. Because if we take this sculpture here, for example, and of course I converted it from an alembic and scaled it properly relative to a Tommy as usual, and I move it up, and with an RBD material fracture I think I used the defaults, I just let it fall down. For now, still without constraints. We'll talk about this in the next chapter, and if this falls down and breaks, you can see that there's one problem, and that is the super hard edges of the breaking area. Under certain circumstances, based on the material, this can be correct. But if we wanted to have something like concrete or something, it definitely looks really CG and wrong. And this is called the interior detail, and we can actually increase that. And not only the interior detail is lacking, also when you look at the actual, let's say, cut, or how you ever want to call it, the edge of our pieces, they are completely straight. So this is something we want to change. In the RBD material fracture, this is already built in, but we will then also see how we can do the same thing if we want to use the Voronoi fracture. But here in the RBD material fracture, everything is already there and handy under the detail tab. And there are two things, like I said, we want to talk about: the interior detail and the edge detail. Let's start with the interior detail. And if I turn this on, and we can look at this without simulating the whole thing by just looking at the pieces with an exploded view, for example, before they go into the simulation. And here you can see what it does. It creates detail on the inner sides of our, breakups. And by default, the settings are not great. It does create details. If I turn it off again, you can see the difference. There you go. But what I usually do, based on the standard size that we work with, usually this is too low. And this is not the noise amplitude as you would think, but the detail size on the top here. So let's lower this to maybe 0.02, and as you might guess, what we get is simply higher res topology. So by lowering the detail size, we increase the resolution of the breakup. And then what the interior detail down here is actually doing is adds noise to it. As you can see, it breaks it up, and you can change how high the frequency should be. And this is usually very slow, because as soon as you change something, it recalculates. So what I often do is I completely turn off the calculation down here, maybe and I set the auto update to manual, and then I just change the numbers, nothing will update. And what I leave the noise amplitude for now, and then I turn it back on, and then I see the result as a whole. There you go. And depending on what you want, this might be good or not. Maybe let's lower this. Also, you can change the noise type. Maybe we can try an alligator here or whatever, but you can see the idea. It subdivides the inner areas, and then it adds a noise on top of that. And that means when we simulate this, it will feel much more detailed. So here you can see on the inner edges, maybe over here, it feels much more like there's actually some kind of material that broke up. And it will definitely help with the illusion that this has a certain type of material. Now, but as you can see, this is only the detail on the inner faces, so to say, but the edge is still very hard. So let's go back to our exploded view. And here you can see what I mean. This hard edge here, the edge itself will not be influenced by the interior detail. It only changes the inner face. But when we activate edge detail, then it will break up that edge as well. Both things take a while, so it's normal that, for a complex geometry that can take a little bit of time, which is the reason why it often makes sense to actually cache what comes out of the RBD material fracture, because you don't want to do it every single time. And it's not perfect, but you can definitely see here that the edge is more broken up. We can make it more visible by just increasing the frequency of our edge detail. So we have the strength again of the noise height and the noise element size. So since it's the noise element size, making it smaller will increase the detail, so to say. And of course, it depends on your geometry. A higher noise scale can be a good idea when you have something, like marble or something. But if you want to have something like concrete, then a smaller noise size makes sense. So here you can see now it's broken up stronger. And this is pretty cool. In combination, you can see how much more interesting the whole thing looks like. And when we sim this again, it can really add to the perception again that this is some material that is breaking here and not some CG geometry. And here you can see how much believability this adds to our pieces. It's pretty nice. Now, sometimes though, you don't want to use the RBD material fracture, like I often don't, because it's pretty slow. And maybe you want to break up, the steps in multiple nodes. So many reasons why you wouldn't use the RBD material fracture. So let's copy our setup here and use a Voronoi fracture. And I will do this with a points from volume. And let's increase the jitter scale a little bit, something like that. Let's see how this comes out. And then a Voronoi fracture. And when we look at the result with an exploded view, we can see we have maybe a bit too many points. So let's increase the particle separation. So here we go. Let's take this one. And as you can see with the Voronoi fracture, we have the same problem. The inner parts are, not very detailed. And for this, there is actually a node that can find those inner pieces, because what comes out of the Voronoi fracture is an inside and outside group. And the node we're looking for is reasonably named RBD interior detail. And this thing expects already the inside group to be used, so it's made to work with a Voronoi fracture. And if we use an exploded view for this, you can see it subdivided it, not by much, but of course we have to increase or lower the detail size to increase the resolution, just like before. Maybe something like this. And then down here we have the same as we've seen in the RBD material fracture, because of course it's the same thing. This here is built in the RBD material fracture, of course. But we can create it ourselves. So let's increase the frequency maybe. And as you can see in my experience, it is faster to do this in a separate node, because basically everything that you've done before, it doesn't have to do again. So in my experience, this is why I prefer this workflow actually. It is a faster workflow to split it up into multiple nodes. And here you can see again how this can look like, much more like concrete. And then we run this through an RBD bullet solver to see the result. There you go. So you can do this yourself, and this is also a nice example of this with a different amount of noise, and it looks much more like concrete now. But what's missing here, as you can see on the edge, again, it doesn't change the edge. Now this is a problem when you work with a Voronoi fracture, because there is nothing like a RBD edge detail or something that doesn't exist, but we actually already seen a node that we can use for that. And that is the Boolean fracture. So if you actually work with a Voronoi fracture, then you can't do it afterwards, unfortunately. The edge lines will always be straight when you use the Voronoi fracture. Nothing you can do about it, to my knowledge. But what you can do is you simply use the Boolean fracture, and what you usually do there is, again, you scatter inside, maybe something like this, and then remember, we just create a grid that we use as our cutting area. And maybe let's make this 3 by 3 meters and give it a lot of resolution, because this is important. The resolution that you give the piece will be, and actually let's do it with a single grid first to see it better, and let's actually transform it afterwards. So we take our sculpture the way it is here, and then we position our grid and use a Boolean fracture to cut our object with that grid. And what we've already seen in the last video is when you do that, let's maybe cut it like this, it takes the resolution of our piece, and it, as you can see here, it uses that topology reflected on the cutting area. And this of course is what we can use here to cover both. First of all, we can increase the resolution to have more detail in the interior parts. And then of course, as we've already seen, we use a mountain or an attribute noise to deform it. And let's give it a nice resolution by lowering the element size, and maybe the amplitude doesn't have to be that strong. So it might be something like this. And you can see now, because this is used to cut our object apart, it will not only influence the inner area in terms of detail, but also breaks the edge up, of course, in the same way. So basically with this technique, you have kind of both. You have an edge detail and an interior detail represented in your geometry that you use for breaking it up. And this is why this technique is very often used by more senior people, because it allows the most control and also adds the most detail potentially. And now I actually wanted to show you that you can also use this with the points from volume, because all you can do is you copy this grid, this deformed grid, onto those points. Then it looks something like this, pretty ugly. And then we just rotate them around, maybe with an attribute randomize orient. There you go. Many other ways of doing this, and then you get this kind of complex cutting geometry, and we use this in our Boolean fracture. And now it takes a little bit to calculate that, of course, but what you get is, of course, a lot of broken up pieces, and that didn't look great. Why is that? Let's see where our cutting area is. Oh yeah, for some reason it's down here, and then you can see I get the broken up version of this, and I can of course increase the strength of the whole thing, obviously, by increasing the amplitude of my noise on my geometry. There you go. And now you can see I get broken up edges, broken up interior detail, and on top a lot of control, because I can always add an additional grid if I want, for example, a cut around here. So maybe I just merge my own version with this. So I position an additional one exactly here, because I want my cut to be there. And now, as you can see, I have all the detail and on top the control coming from the Boolean fracture. So I kind of get, again, the best of all worlds. Cool. So, and if we simulate this, finally, it looks like this. And you can see, besides the actual pieces, what we can also control and should control is how those pieces are then broken up. And here you can see how complex this shape can be when we do it right. Now, one thing to keep in mind, though, sometimes it might be necessary, if you have a super detailed geometry like this, if your pieces are too complex, that you might have to decompose them again. So if you look at our pieces here, a convex decomposition might be necessary for the right collisions if you want really detailed interactions. And then you might want to simulate with this version of your geometry and use the high-res version with all the detail as a so-called proxy, or the high-res version. This is then the simulated version, and this is the version that you would render. And this is something we want to talk about in a later video. Just as a side note, in most cases you will be fine using the high-res version for simulations, but sometimes if your collision isn't correct enough, then you might have to create a version purely for the simulation. We will look at this at the video about low to high or proxy geo. So if you want to search it, it's in the constraints chapter. But for now, this is all about adding detail. So what we've seen is all of this is built in the RBD material fracture, and this is probably the best way to start. It's separated into the interior detail, which is the inner face detail. Keep in mind that the detail size up here controls the size of the subdivision. And then we have edge detail, which controls how the actual edges look like, and it's often a good idea to break those up as well, and this is already built in. What the interior detail is doing is something you can also do yourself. If you, for example, use the Voronoi fracture, then you can just use the RBD interior detail simply to subdivide the inner faces and then add a noise to it. So before it looks like this, and then afterwards it looks like this. Pretty straightforward. Unfortunately, what you can't do as a post process, so to say, is changing the edge distribution or the edge complexity. If you want that in your own setup, then you would need to use the Boolean fracture that we learned in the last video. And this is actually why a lot of more senior people use this approach over the Voronoi fracture and the RBD material fracture, because it allows you to add additional detail to your geometry while also having control how the pieces exactly look like. And while doing this, it also breaks up the edge of the cutting. So a lot of things that automatically come by using the Boolean fracture, so to say, it's just a bit more work. So yeah, this is how you can add additional detail to your breaking pieces, to your fracturing. And there are different ways depending on your approach. So I hope this is helpful. Thanks very much and see you later. Cheers.